Okay, hello, welcome back. So this is sort of following on from the previous video I did where we were picking colors from the screen in our little mini editor. So here, for example, I've got a bunch of triangles and I can click somewhere on the screen and I can pick the color which is at that pixel. Now, the extension to that is now I want to modify it so that I can sort of pick on the screen and somehow get the index or the ID of the object which is drawn to that pixel. So I've done a few things to get us started up. First of all, I made this triangle class which stores a number of properties, specifically very important, storing an ID property, a position, and a color. And this is all used to control how the object is displayed on the screen, except for the ID. Pretty normal stuff. I've got the canvas widget that I made in the previous video. The window has got a list of objects, which we're creating here. You can see we're creating them with their own IDs. Furthermore, when we create the OpenGL canvas widget, we pass along that list of objects so that when the OpenGL canvas redraws itself, it has access to that set of triangles and it can draw them. I'm not sure if I talked about this before, but I went ahead and abstracted all the vertex buffer stuff into its own class. And this is a pattern that I think is pretty elegant for vertex buffers and other objects, is we have an initializer and then we have potentially a whole bunch of different functions which can initialize the resources for different uses. For instance, this RGB triangle. And what this does is it actually returns a reference to itself. And the thing which is really cool about that pattern is that then when we actually create that object, we can chain these operations together. So here I'm creating the vertex buffer and then I'm immediately initializing it to hold an RGB triangle, and that gives me the instance that I can save in a variable. I haven't really modified the triangle shader too much. All I did is I added in a position or a translation uniform and a color uniform. And you can see here how this is being used to set the position of the triangle on the screen as well as its color. I'm querying the locations of those uniforms down here. And then when I come to render, I will upload that data. We can see if we go down to the PaintGL event, for each triangle in that set of objects, I am uploading its position and color, and then I'm just drawing the mesh. What I'm going to do now is I'm going to start modifying the frame buffer so that we can save the object ID for every visible object. So you'll see that I have this color attachment texture, and it's pretty much just a normal texture. What I'm going to do is I'm going to add another type of texture, and I'm just going to call this an object ID attachment. Really what this is it's a texture which can just store a single unsigned integer. A lot of this is not going to need to change, but when I come down here to GL text image 2D, I'm going to specify a different storage format. So I'm going to store 32-bit unsigned integer with just one component. I'm going to take this in and allocate space with the red integer layout. This data type will be unsigned integer. So that has declared or allocated that storage for the texture. All of this, I think, can stay the same. There's just one difference that I'll make, and that is I'll use nearest filtering. Now, the reason for this is, let's say that we click on the border between two objects. It would not make sense to linearly interpolate the object IDs. I want to pick the exact, like, pixel perfect ID. Now, just to be clear about this, I can probably, here's a little confession. I spent a long time debugging this. I'll tell you what it was later, but it had the effect of me being very cautious about being explicit with color attachments. So we've got this texture that we're rendering color to, that will be color attachment 0, and then we'll have this other texture that we're rendering object ID to, that will be color attachment 1. And what I'm also going to need to do is track which color attachments my frame buffer will render to when we start drawing. So I'll do that with a variable. I'll call it draw buffers. That'll be a list of integers. When we make the color attachment, I'll go and append. So we're specifying this is attachment 0 that we're rendering to, and then when I make the object ID, I will append attachment 1. This will be used down below when I start drawing to the frame buffer. So what I'll do is, first of all, I'll bind my frame buffer, and then I will specify which buffers we'll be drawing to. Just like that. So then, of course, we can go down to our canvas, just where we go and initialize everything. And down the bottom, I've got this frame buffer. And what I'll do is add that attachment. Now, I did find that in practice, for whatever reason, I needed to actually create the frame buffer before I created the shader, because this shader is going to be configured so that it writes out to multiple render targets. But strangely, that's not sufficient to indicate at shader compilation that multiple render targets should be used. I'm not saying I 100% understand or agree with this. I just found when I got this into RenderDoc that the frame buffer needed to be declared and specified before the shader. But anyway, to recap, I've now got two color attachments or two render attachments, my image that I'm drawing and the snapshot of every object ID. So what I'll do is I'll go down to the fragment shader and I'll bring this in. So I'm also going to have an ID, and then I'm going to have two outputs basically. So color buffer 0 will be the actual color, and color buffer 1 will be the object ID. And then setting that is as simple as just setting the variable. So we'll say object ID is whatever ID we got in there. So I should probably fetch the location of that uniform . What I'll do now is I'll go down to the render function and I'll put this in. I'll go uniform one unsigned integer. That will go to my ID location, and I'll upload the object's ID. If this is working, and it's probably a good idea just to run it. Yep, it's working. What is happening under the hood is that in addition to this texture that we can see on the screen, the IDs of each of these respective objects is being written out per pixel to a separate texture. So what I'm going to do is I'm now going to retrieve that info from, oh my goodness. You just get a wall of text some days? Okay, I'm going to retrieve that info from the frame buffer. So I'll go down here and I'm just going to call this pick ID, I guess. And I want to just return an integer. Now, as we can see up above, we bound our frame buffer object as the GL read frame buffer, but this is not explicitly telling it which attachment to read from. And the default is a color attachment 0, but we can specify that with the glReadBuffer function in the case of color attachment 0, and in the case of ID that will be attachment 1. Okay, so next we will go through the normal process. We'll go ahead and bind our pixel buffer object to the pack buffer that's ready to receive the pixels, and then we'll read the pixels. Now, this is the bit that tripped me up. Looks pretty good, right? Let me just go. I'll switch that around. That's probably fine. Now, if I go and do this, and I click, I will get this message here that it was an invalid operation. Now, unfortunately, the OpenGL documentation is pretty good, but it just didn't specify exactly what's happening here. And it turns out this took me like a week. I'm so embarrassed. But we need to specify glRead integer. Now, if we were to do this, something is happening, at least. I'm going to just go ahead and map that buffer, and it'll be an unsigned integer pointer. And then I can just return the contents of that, the unsigned integer. And if I just go back to the main window, I'll just modify this quickly. There we go. So I'm just going to print out to the terminal for now. So yeah, if I click on the black space, of course, the default value is 0. So 0 is probably a bad ID for this red triangle, but it's there. And then if I click on this triangle, that's object 1. This is object 2. This is object 3. So now we can use these IDs to index into the main set of objects, and we can fetch any properties we want. So if this were a more complete demo, I would be able to click on this triangle and get some properties of the triangle sort of populated up here or something like that, which is really very, very important for making a map editor or something. It's really good to be able to click on the screen and see exactly which object you clicked on. That will be it for now. Short and sweet. Full code will be linked for Patreon members and channel supporters. And yeah, all the best. Hope to see you soon. Bye.